Hello, in this video we're going to be writing the equation of exponential growth and decay given a graph or an input-output table. So to get us started, let's take a look at our equation. This is the equation that we have been using, and there's a couple things that you need to know. This A happens to be our initial value, which is essentially our y-intercept. The other thing that you need to know is B. Okay, so if that B is greater than 1, then we consider this to be exponential growth. If the B is between 0 and 1, then we say it's decay. Okay, the main part of what we're going to do today is going to be to write the actual equation. So the first thing we're going to find is the B value. So first we're going to find B, and all you need to do is take any two consecutive output values, and I want you to do a ratio. You're going to put the new output over the previous output. That ratio will give you the base. The next thing you're going to do is you're going to find your A value. That's your initial value. You could do this one of two ways. The first way to do it is to look at your graph or look at the input-output table. Since the A is your y-intercept, this is going to be when x is 0. If you can see that on the graph, great, no need to solve for it. If you can see it on the input-output table, again, no need to solve for it. But if you cannot, then you need to solve for it algebraically. And all you do is take a point, any point that you can clearly read off the graph or the table, substitute the point and the B into this equation right here. Once you put your x, y, and b, that leaves you with A, and you just solve for it. Once you have the A and the B together, then you just put it into the equation, and it's done. All right, let's do lots of practice questions to make sure you've got it. Let's start with some easy and build to some more complicated problems. So let's take a look at this one. As x gets larger, let's see what happens to our output values. They seem to be going down. Therefore, this is decay. And what that means is that our base, our B, is actually going to be less than 1. This is helpful because if I do my ratio to get my base, and I did it incorrectly, common sense should tell you that you're right or you're wrong. Okay, so to get the base, all you're going to do is take any two consecutive outputs, and you're going to do the newer one over the previous. So the newer output is the 9 and the previous one is 27. This is going to give us 1/3. So let's just make sure this makes sense. If I multiply 81 by 1/3, yep, I get 27. If I multiply 27 by 1/3, I do get 9. If I multiply this by 1/3, I do get 3, and so on. Okay, now the next thing we need is our initial value. The initial value is our y-intercept, and that is clear that it is 81. So when I put those two pieces together, I get y is equal to 81 times 1/3 to the x power. Okay, let's try the next one. As x gets large, let's take a look at our y values. Those also get large. Therefore, this is growth. To get my B, I'm going to take any two consecutive output values, and I'm going to do the new over the previous. So that means I'm going to do 6 over 3, and that means my base is 2. So let's just make sure this works. If I multiply 3 times 2, yep, I get 6. Times 2, yep, I get 12. Times 2, I get 24, and so on. This is definitely exponential. My initial value is my y-intercept, and that's right here. So that would be 3. Let's put it all together. You get y is equal to, and keep in mind that the formula is a times b to the x power. So your answer is y equals 3 times 2 to the x power. Let's look at the last one on this page. As x gets large, my y values are getting smaller. Therefore, this is decay. Let's get our b. You're going to do new over the previous. All right, pick any two. I'll pick these two because they're easy. So the newer value is 5 over the previous value, which is 10, and that gives us 1/2. Now, just so that you know, if you mixed up this ratio and put 10 over 5, which is incorrect, that would give you 2. Clearly, we are not multiplying by 2 here to get from one place to another. So hopefully common sense would tell you that this is wrong. It's 1/2. And I can test that real quick. Half of 10 is 5. Half of 5 is 2.5. Half of that is 1.25, and so on. My initial value, well, that's my y-intercept. So my y-intercept here is 10. Put it together. Y is equal to 10 times 1/2 to the x power. Let's do a few more. Okay, as x gets large, this is getting large, this is clearly growth. My base, you're going to do new output over previous. So I'll take those two, so that means 18 over 6, which means 3. So it looks like my outputs are tripling. My initial value is my y-intercept, and that is 6. So put it all together, you get y is equal to 6 times 3 to the x power. Let's take a look at this one. As x gets large, y gets smaller. This would be decay. Okay, my base. Take any two output values that are consecutive, and we're going to do new over previous. So that's 300 over 900, which looks to be a third. Now the next thing that we're going to do is we're going to find our y-intercept, and that's right here, so that's 900. So your final equation is y equals 900 times 1/3 to the x power. So those are pretty basic. Now we're going to do one that's a little bit harder. Okay, growth or decay, as x gets large, this is getting smaller. Clearly this is decay. Your base, find any two, doesn't matter, consecutive, and you're going to do new over the previous. So that looks to be 2 over 4, which is 1/2. Great. Now I need my initial value. Well, this is what makes this one a little bit harder. You could do one of two things. If you want to get your initial value from the table, well, you can just basically work backwards. So if you notice, you're multiplying all of these by 1/2. So times 1/2 gives you 2, times 1/2 gives you 1, times 1/2 gives you 0.5. Go the other way. So if I go the other way, essentially half of what was 4? Well, half of 8. So that means my initial value is 8. Now you could do that, or you could do this. Y is equal to a times b to the x. Pick a point, any point. I like 2, 2 because it's easy. So that means my y value is 2, my x value is 2. I don't know my a value, but I do know my b value is 1/2. So 2 is equal to a times 1/2 squared. So 2 is equal to 1/4 a. Well, now all we have to do is solve for a. So I think I'm going to multiply both sides by 4, and I get 8 is equal to a. Put it all together. Y is equal to 8 times 1/2 to the x power. Let's try another. Okay, as this gets larger, Let's take a look at what's happening here. It's getting bigger, so this is clearly growth, which means this b must be bigger than 1. So take any two values here and let's do 7,500 divided by 300. That looks like my base is 25. So each of those must be multiplied by 25. Now, to get my initial value, I could do one of two things. I could actually continue this table in the opposite direction. So what that means is if I multiply by 25 to get the next value, then going in the other direction instead of multiplying by 25 would be divide by 25. So I could do that. I could do 300 divided by 25, and I could put that in, and that would be 12. I could divide 12 divided by 25, and that's going to give me 0.48. Okay, so 0.48. Now that's one way you could do it. The other way that I listed in your directions is to take your y is equal to a times b to the x and pick a point, any point. So if I pick, say, the first point, because this looks to be the easiest, so I pick 2, 300, that's my x, that's my y. So I'll put the 300 for my y, leave the a because that's what I need to find. My b is 25, and my x is 2. So I'm just going to solve. So 300 is equal to 625a. To solve for a, I'm going to divide both sides by 625. And good thing I have my calculator. I'm going to do 300 divided by 625, and guess what? A is equal to 0.48. So my equation is y is equal to 0.48 times 25 to the x power. Let's try another one. Okay, you notice they're getting more complicated here. So as x gets larger, my y values are getting smaller, so clearly this is decay. That means my base is going to be between 0 and 1. So I need to do a ratio of new to previous. Now I'm going to choose the easier numbers here. I'm going to go with those two. So my newer value is 19.2 over my previous value, which is 30.72. So I'm just going to divide that. I've got my calculator here. So I'm dividing that, and I get 0.625. Now, that actually is 5/8. It doesn't matter. I'll use 0.625 just because I think that's the easiest. Now my initial value, again, I could continue my table going the other direction. So I could do that. So instead of multiplying by 0.625, right, because if I work this way on my graph, I will multiply by 0.625, and that's going to give me this answer, and then I'll multiply by 0.625, and that's going to give me this answer, and I multiply by 0.625. Going the other direction, I would just divide. So I could do that twice if I really wanted to. So I could take 125.82912, and on my calculator, whoops, it would help if I typed it in correctly. Okay, and that's going to give me a big number, 201.326592. I'm going to do it again. I'm going to divide that by 0.625. So I'll divide that by 0.625. And my guess is that's going to give me another large decimal. So it's 322.1225472. Yikes. So I'm going to say my initial value is, we'll just round this, 322.1223. The other way to get this value is to do y equals a times b to the x. Pick a point. I'm going to go with this one because I think it's the easiest. That means 6 is your x value, that's your y value, so I'm going to say 19.2 is equal to a times 0.625, and the x value would be 6. So now on my calculator, I'm going to do 0.625 to the 6th power, and that is going to give me something really crazy. So 0.0596044645. I'm going to divide both sides by that. So A is approximately, so 19.2 divided by, now I'm going to use some funny buttons here, and guess what? I'm going to get the same exact thing. Okay, so my final answer is y is equal to 322.11, nope, sorry, and let me actually write this correctly, 1, 2, 3, and actually I've got an extra 2 up here. I shouldn't have an extra 2 up here, times 0.625 to the x power. Oof, that was the hardest one. Alright, now let's take a look at a graph. So clearly, because this is going down, this is always decreasing. Always decreasing, that means this is decay. I need any two consecutive outputs. Any two. So if you notice, I have 0, 5. There's a point. I have 1, 4. I have, oh, I don't know what that is. I don't know what that is. That's between. So it looks like these are the only two consecutive points that I know for sure. The good thing is that's my initial value. So I can put that 5 right in here. To get your base, you're going to do new over previous. So that would be 4 over 5. So your equation is y equals 5 times 4/5 to the x power, or if you divided it, because this is the same thing as 0.8, you could say 5 times 0.8 to the x power. Well, that wasn't bad. Let's try one more graph. Alright, I can't see my y-intercept, so that's going to be a problem. But I do see a couple of points here, which will be helpful. So I see this one, which is 1, 1, and I see this one, which is 2, 2. Clearly this is going up. This is always increasing, so this is going to be growth. Your base, you're going to do new over previous. So your new value would be 2 over 1. So it looks like this thing is doubling. I don't know my initial value. So what I think I'm going to do is I think I'll just try my y equals a times b to the x and take one of these 2 points. I think I'll try the 1, 1. So 1 is equal to a times 2 to the first power, right? Because that's my x, that's my y. So 1 is equal to 2a. Divide both sides by 2, and I'm getting a is equal to 1/2. And if you look on the graph, that certainly looks like it's 1/2. So your final equation is y is equal to 1/2 times 2 to the x power. Okay, and that is all. I have some practice questions that I would like you to try. Give those a try. Feel free to use the work. I will have another office hours session on Thursday if you would like to join me to get a little bit of extra help on this, because this is one of the tougher topics that we do. But I try to keep your homework questions not so messy, so they should be pretty easy for you. But good luck. Let me know if you have any difficulty.